Greetings to all of you. In today's session, we are going to start with the chemistry for entrance examination and the competitive exam and the international floor, national level India JEE Advanced and JEE Mains examination, NEET Chemistry, Telangana EAMCET examination for engineering stream and Andhra Pradesh EAMCET exam for engineering entrance exam. In addition to all these, if you are preparing for any competitive examination, this kind of explanation will be very much helpful. Let's enter into our today's session. And the first question related with the IUPAC nomenclature. IUPAC stands for International Union for Pure and Applied Chemistry. Name the following compounds based on IUPAC nomenclature. This is the compound provided where ketonic functional group and secondary amine is there. In either double bond is also present. Parent chain is having 5 carbon length. And this is the compound we need to assign its name as per IUPAC nomenclature. So among all, the right option will be 4, N, N dimethylamino penta-4-ene 2-one. This will be the right naming for the given organic compound. Let's see how can we assign name for this compound. As per that, ketone will be taken if ketone is the prefix. So if ketone is the main functional group, then we have to assign -one. And if ketone is the side chain, that can be taken as a oxo, right? So here in this compound, we have amine, double bond, ketone. Among all, highly oxidized one will be ketone, no? That's why ketone will get higher priority so that it will be taken as -one. And being it is the kind of 5 carbon length chain, so that we will mention it as a penta. Root word will be taken as a pent, and -one is present at second place. 2-one will be there. Let's see what else we have. Okay, either numbering will be started from this carbon right hand side or else the left hand side. Both the provisions we have actually, but numbering always started from highest priority functional group side. Okay, ketone will be present on the second carbon from left hand, fourth carbon from the right hand. Least distance is most preferable. That's why it can be taken as a 2-oxo. Right, so 2-one is more preferable rather than 4-one. That's the reason why numbering will be started from left end. 1, 2, 3, 4, 5 is assigned in this manner. And if you see fourth carbon is having multiple. One is amine, second is double bond. Both we need to assign on fourth carbon itself. On this fourth carbon, nitrogen is there. This nitrogen is denoted as the tertiary amine. Tertiary amine in the sense, if nitrogen is located with 3 alkyl in its vicinity, that is called a tertiary, right? Here, these methyl are located on the same nitrogen, no? So that we have to mention N, N dimethyl. Where this is present, that is on fourth carbon. And being it is the side chain, we need to assign in the bracket. Okay. 4, N, N dimethyl. And it is taken as amino, and 5 carbon is the parent chain, so that penta, and double bond is present on the fourth carbon, 4-ene. Ketonic group is residing on second carbon atom, 2-one will be there. This is the entire naming as per the IUPAC protocols for N, N dimethyl amino penta-4-ene 2-one is the right representation of IUPAC nomenclature for the given organic compound. For question number 1, option number A will be the correct answer. Move on to question number 2. Methane burns in oxygen to produce carbon dioxide and water. Methane represented with the CH4 and oxygen represented with O2, and carbon dioxide water will be generated. In order to get carbon dioxide, here methane upon treating with burned with the combustion denotes what? Burning in the oxygen air is called a combustion process. Methane upon addition of oxygen, formation of carbon dioxide will be there, and 4 hydrogens are there. Here the formation of water will be there, H2O water. In order to balance 4 hydrogens, 2 will be taken as the coefficient. If we count 4 oxygens are there, 2 plus 2, and 1 carbon is there in the both sides. 4 oxygen atoms, 2 plus 2. 4 hydrogens, 2 plus 2. So that entire equation is perfectly balanced for the combustion of methane with the oxygen. That is given in the option number B. Move on to, here it is if we want to give the entire representation of the equation, their physical forms also mentioned. Methane being it is a gas denoted with G, and oxygen also gas. Carbon dioxide gas, water is also under vapor conditions is a gas itself. Upon combustion, vapor will be generated. So that all the reactants and products are existing in a gaseous form. This is the way we can denote a complete combustion of methane with oxygen. Move on to question number 3. This is the question based on IUPAC nomenclature. And the second question is taken from the Cambridge Assessment International Education. And question number 3 is taken from JEE Advanced 2023 question paper. Fine. The complex which can exhibit the type of isomerism shown by platinum NH3 taken twice Br2. This is the platinum complex is. Okay, so if we know the geometry of this platinum complex, it is obvious to deduce the geometry which resembles this whatever resided by platinum complex. The platinum complex exists in square planar. All the platinum complexes are square planar. Platinum palladium exists in square planar complexes, so that what else compound in the given options also having that kind of square planar geometry we have to identify. So again we can find a platinum complex. So it's very simple to identify. This will be the right answer, because again here platinum is accompanied by the 4 ligands. How can we say 4 ligands? En denotes what? Ethylene diamine they only given. Within the question hint is given ethylene diamine. Ethylene diamine is said to be a bidentate ligand. It able to form a chelate complex, right? Chelation will be generated, which is highly stable, right? So it is a bidentate. 2 ligands, it works like a 2 ligands. SCN taken twice, so that these 2 ligands are there. Total 4 ligands are able to occupy square planar geometry around the platinum metal. So this exactly resembling the problem question which is given as platinum NH3 taken twice Br2. If you go with zinc, NH3 taken twice Cl2, it is the tetrahedral complex. Platinum NH3 taken twice Cl4. If you observe, if you count the number of ligands, 4 chlorines are there, 2 amino are there, coordination number of platinum will become 6. Hence, it will be octahedral geometry, so that we can't map with this. In another chromium, En taken twice, being it is bidentate, able to form a 4 bonds. Water, aqua, 1 bond. Sulfate, again 1 bond will be there. So that 4 plus 1, 5 plus 1, 6 bonds. So that again we can say chromium complex is also of octahedral. Starting one is a square planar, second one is a tetrahedral, third one is a octahedral, fourth is also octahedral as well. So that we can simply identify A will be the right answer. Let's see exact geometry of all of these options provided. Platinum diamino dichloro complex is provided in both possibilities, either 2 chloro on the same side, 2 chloro on the opposite edges. We can say same side is called cis, opposite edges called trans. Both the possibilities we have for the problem question, that is platinum NH3 taken by Br2. Later on, the resembling molecule called ethylene diamine, being it is a bidentate, it able to form a chelation like this. And another NCS ligand is there where we can bind a nitrogen with this platinum, and it exists in square planar. And there are 3 possibilities we can write in different forms, no? So that these many possibilities you can write, but all these cases we can say all these are square planar only. So this will be exact mapping. Move on to another zinc. Zinc, if you observe, 2 amines are there, 2 chlorines are there, but it is the kind of tetrahedral in nature. Tetrahedral, there is no relation with the square planar, so that we can discard. And platinum complex, if you see, 2 amines, amino groups are there and 4 chloro are there, so that we can simply say it is the octahedral complex. 4 are laying on the equatorial, 2 are laying on the axial position, so that it is a octahedral complex. In either last one is chromium, being it is attached with the ethylene diamine bis. So 2 ethylene diamines are denoted with bis ethylene diamine. And it is convenient to write in the opposite edges because it is more stable. Trans-ethylene diamine, all the chelation opposite far apart so that we can minimize the steric hindrance. And axially we can locate aqua and sulfate molecules, and this is the complex ion cation, complex cation we can say. And here also we clearly observe octahedral geometry. So that right answer will be option number A. For question number 3, option number A will be the correct answer. Move on to question number 4. The correct statement related to the process involved in the extraction of metal. We are going to extract the metallurgical process based question. It will be, again it is the part of JEE Advanced 2023 question paper. Roasting of malachite produces cuprite. Let's see whether it is correct or not. Calcination of calamine produces zincite. Copper pyrite is heated with silica reverberatory furnace to remove the iron. Impure silver is treated with aqueous potassium nitrile in the presence of oxygen, followed by the reduction with zinc metal. These many options, how many are correct, we will see. Among all, B, C, D are the correct answers. In the left only A option will be wrong. Okay. So what they are saying, roasting of malachite produces cuprite. Okay. So cuprite, malachite which oxidized copper ore can be used to produce the copper. But here the process we are applying is called leaching. So leaching process will be followed rather than that what they are saying roasting process. So that option A is discarded. Option B, calcination of calamine produces zincite. Calamine can be mentioned with a zinc carbonate. Upon heating, what they are asking for, calcination. Calcination denotes what? Removal of carbon dioxide is called calcination. Removal of carbon dioxide at higher temperature. Being it is a carbonate or calamine is a zinc carbonate, can be heated at higher temperature, decomposed to give zinc oxide called zincite, and excluding this carbon dioxide as a gaseous component. This is the right explanation. Copper pyrite is heated with silica in reverberatory furnace to remove the iron. Copper pyrite is mentioned with the copper iron sulfide. Here iron is also present in the minute quantity. Upon treating, what they are saying, combustion, heated with silica. Fine. Whenever copper is heated with first burned, so that copper sulfide, iron sulfide got separated, separate compounds will be formed. Later on, iron sulfide, whatever there can be bounded to the oxygen. Excessive oxygen is there, so that all iron converted into oxide form. Iron oxide now treated with silica, sand, so that iron silicate will be formed. This iron silicate is called a slag, which is an impurity. We can simply discard this one. And copper sulfide will be separated. This is the way copper pyrites can be purified in the metallurgical process. Impure silver is treated with aqueous potassium nitrile in the presence of oxygen, followed by the reduction with zinc metal. Okay, so it is the kind of extraction of silver metal. Extraction of silver metal, we can say. In order to extract the silver metal, potassium nitrile is treated. Potassium nitrile, when added under moisture conditions in the presence of excess of air, here the complexation is possible, so that we will get silver nitrile compound. The silver nitride further treated with metallic zinc. Metallic zinc, what is the nature of metallic zinc? Reducing agent. Being it is the kind of +1, silver existing in the +1 oxidation state further turned into silver metal, and zinc is converted into zinc tetranitrile anion. This is the kind of extraction of metal by treating with potassium nitrile and subsequently zinc metal. Fine. Whatever they said, exactly correct. Okay, B, C, D are a correct representation for metallurgical extraction of metals, but first one is wrong. For question number 4, B, C, D are the right answers. Move on to next question, question number 5. This is the question given in the EAMCET 2023 question paper. The radius of third orbit of hydrogen atom is r picometers. Okay, hydrogen third orbit, radius of third orbit of hydrogen is given as capital R picometers. The radius of second orbit of helium plus ion in picometers. Hydrogen is given, helium plus should be identified. The correct answer will be 2 by 9 R. Let's see how it is possible. Okay, helium plus ion. In case of helium plus ion, Z is equal to 2. Z means atomic number, and orbit laying in third level, n is equal to 3 is assigned for this one. If you apply the formula n square h square by 4 pi square m z e square, 3 square h square, n value is 3, so that 3 can be taken as a power 2, and h square 4 pi square m into z e square can be taken. Z value is taken as 2. If you substitute all the values, 9 by 2 into 0 0.529. 0 0.529 is the value. H square by 4 pi square me square is the value for hydrogen. Hydrogen's value is given as R, no? So that let's put R over here, 2 by 9. R will be the right answer. For question number 5, answer number 4 will be the correct answer. Move on to question number 6, last question of the session. Consider the following. It is the question given from the periodic properties, most important session. The order of first ionization enthalpy, first 3 elements of third period. Third period elements are provided. One is sodium, second is magnesium, third is aluminum. The right order will be magnesium, aluminum, and sodium. So this will be the order they provided. We have to interpret whether it is a correct or not. The element with electronegativity 3.5 is chlorine. Chlorine electronegativity is assigned as 3.5. Correct or not? The order of sizes of ions Mg plus 2, Na plus, F minus, O minus 2 are Mg plus 2, sodium plus, F minus, O minus 2. This is about what size, increasing order of their size is provided. All these cations and anions together are aligned in the increasing order of their size. Last one. The IUPAC name of element with atomic number 106 is a borium. IUPAC name of the element atomic 106 element is a borium. They are same. We have to identify correct or not. So same statements are provided in Telugu. క్రింది వాటిని పరిగణించండి. మూడవ పీరియడ్ లోని మొదటి 3 మూలకాల ప్రథమ అయోనైజేషన్ ఎంథాల్పీ క్రమం మెగ్నీషియం, అల్యూమినియం, సోడియం. రుణ విద్యుదాత్మకత 3.5 గల మూలకము క్లోరిన్. Magnesium plus 2, sodium plus, F minus, O minus 2 అయాన్ల సైజుల యొక్క క్రమము. మెగ్నీషియం ప్లస్ 2, సోడియం F minus, O minus 2 గా ఉంది. పరమాణు సంఖ్య 106 గల మూలకము ఐయుపాక్ నామము బోరియం. ఈ అన్నిటిలోకెల్లా సరైన వాక్యాలు ఏవి? సో లెట్స్ సీ వన్ బై వన్. 1 2 correct, 3 2 correct, 1 3 correct, 2 4 correct. Among all 1 and 3 are perfectly correct. Let's see what are they. The order of ionization enthalpy of first 3 elements magnesium, aluminum, sodium is the correct representation. Order of sizes magnesium, sodium, fluoride, oxide are represented this way. So 1 and 3 are the correct answers. Let's check. So if you see the elements like silicon, aluminum, magnesium, and sodium, the right order should be silicon should be highest, next is about aluminum, next is about magnesium, next is about sodium, because left to right, all these are laying on the same period, no? Left to right, as we are ascending, what happens? Ionization potential values gradually increases. This should be the order, but in practical sense, it may not be the correct one. But in the practical sense, magnesium is having higher potential than the aluminum. This is explained by taking their electronic configuration. Magnesium is accompanied by 1s2, 2s2, 2p6, 3s2. 1s2, 2s2, 2p6, 3s2 will be the electronic configuration of magnesium. So if you observe, all the orbitals are completely filled. Completely filled orbitals are more stable and very difficult to remove the electron. Hence, it is accorded with the higher ionization potential. If you see the aluminum, 3s2, 3p1, only one electron is there in the 3p orbital, so that it is very easy to remove that electron. Hence, aluminum is comparatively least. And followed by what element we have to consider? Sodium. According to the periodic law, left to right gradually ionization enthalpies increases. Being sodium is the first main group element, we can say its ionization enthalpy will be least. Later on aluminum, because one electron is there in the 3p orbital. Magnesium highest ionization enthalpy, that is because completely filled electronic configuration is there. And one more point we need to explain, the order of sizes of ions like magnesium, sodium, fluoride, and O minus. Very simple trick to identify this order is, larger the charge on the anion, larger will be the size. Larger the size on the cation, smaller will be the size. Reverse can be operated. Larger the size of anion, larger will be the size. Smaller the size and the cation, smaller will be the size, larger will be the size. Okay. If you see magnesium +2 means a large size and cation, so that smaller one. Next, monocation will be there, so that we can assign magnesium followed by sodium. Always anions are larger compared to cations, so next level will be monoanion. So one negative charge will be somewhat larger, two negative charges are largest anion it will be. So this will be the correct representation. Let me repeat once again. As charge and the anion increases, size of the anion increases. Charge and the cation increases, size of cation decreases. That's why +2 is least, -2 is highest. So option number 1 and option number 3 will be the correct answer for question number 6. That is given in the option number C. By this, we entirely completed the session in the detailed way. Hope this kind of session will be very much helpful for your content preparation. I'm sincerely requesting for to like this channel and comment wherever you exactly need the content and what kind of things we need to introduce further, and share with other people who are seriously aspiring for the examinations, and subscribe the channel in order to get more such kind of informative sessions in our near future. Thank you very much for your patient listening. Thank you, one and all.